What if the biggest space breakthroughs of your lifetime haven't happened yet? No sci-fi, no hype, just the real timeline of when humans actually leave Earth behind. Have you ever looked up at the night sky and wondered when we'll finally be living among the stars? It feels like we've been promised flying cars and Martian colonies forever. So what's the real story? When can we actually expect to see humanity's next giant leaps in space? Let's break down a realistic timeline for the future of space travel, from what's happening right now to the incredible possibilities a century from now. First, let's talk about the next decade, the 2020s. This is the era of commercialization and a return to the moon. Companies like SpaceX and Blue Origin are completely changing the game. SpaceX's Starship is the key player here. This fully reusable rocket is designed to dramatically lower the cost of getting to orbit. Think of it like this. Right now, launching a satellite is like buying a brand new airplane for a single flight and then throwing it away. Starship is like having an airplane you can refuel and fly again and again. This is a total game changer. We're already seeing its impact with Starlink, a satellite internet constellation that's bringing connectivity to remote parts of the world. By the end of this decade, expect regular, almost routine flights of Starship to low Earth orbit, deploying satellites and maybe even private space stations. And then there's the moon. NASA's Artemis program is in full swing. The goal isn't just to plant a flag and come home like we did with Apollo. This time, it's about establishing a permanent human presence. Artemis plans to land the first woman and the first person of color on the lunar surface. We're talking about building a lunar base, the Artemis Base Camp near the moon's south pole. Why there? Because we've discovered water ice in the permanently shadowed craters. This ice is like gold in space. We can melt it for drinking water, split it into hydrogen and oxygen for breathable air, and most importantly, use it to create rocket fuel. This means the moon could become a cosmic gas station, a launching point for missions deeper into the solar system. By 2030, we could see the first long-duration stays on the lunar surface, with astronauts living and working there for weeks or even months at a time. Now let's jump ahead to the 2030s and 2040s. With a foothold on the moon, our sights will be set firmly on the red planet Mars. The journey to Mars is no small feat. It's a 6 to 9 month trip one way, filled with challenges like radiation exposure, psychological strain, and the need for a completely self-sufficient habitat. The work we're doing on the moon in the 2020s is crucial practice. We'll test our life support systems, our habitats, and our ability to use local resources to survive. The first crewed missions to Mars will likely be orbital missions. Astronauts will travel to Mars, orbit the planet for a period of time to conduct research from above, and then return to Earth. This is a vital safety step before we attempt a landing. Think of it as a final dress rehearsal. By the late 2030s or early 2040s, we could witness that historic moment, the first human footprints on Martian soil. These initial missions will be short stays, focused on setting up a basic habitat and exploring the immediate surroundings, searching for signs of past or present microbial life. Moving into the 50s and 60s, our presence on both the moon and Mars will begin to mature. The Artemis base camp on the moon will evolve from a small outpost into a bustling scientific research station, maybe even a tourist destination for the super wealthy. Imagine spending your honeymoon with a view of Earth hanging in the black lunar sky. On Mars, we'll move beyond short stays. The first Martian base will expand, powered by solar energy and potentially small nuclear reactors. Astronauts, or maybe we should call them Martians by then, will be living there for years at a time. Their primary job will be exploration and science. They'll use pressurized rovers to travel across the Martian landscape, drilling into the ground, analyzing ice cores, and continuing the search for life. A key technology we'll need to master is in situ resource utilization on a large scale. We'll be manufacturing rocket fuel on Mars for the return trip to Earth, making the whole endeavor much more sustainable. This period will be all about learning to truly live off the land on another world. So, what happens after we've established ourselves on Mars? Let's look further into the future, to the second half of the 21st century and beyond, from the 70s to the 2100s. This is where things get really exciting. With robust bases on the Moon and Mars, the solar system starts to open up. We'll be looking at missions to the asteroid belt. Asteroids are treasure troves of valuable minerals, from iron and nickel to platinum and other rare metals. Asteroid mining could kickstart a true in-space economy. Instead of launching everything from Earth's deep gravity well, we could build large structures, spaceships, and habitats in orbit using materials mined from asteroids. This would be a fundamental shift in how we operate in space. We'll also start sending robotic and eventually human missions to the fascinating moons of Jupiter and Saturn. Imagine a submarine exploring the subsurface ocean of Jupiter's moon Europa, or a drone flying through the thick nitrogen atmosphere of Saturn's moon Titan, which has rivers and lakes of liquid methane. These worlds are some of the most likely places in our solar system to find extraterrestrial life, and by the end of this century, we might finally have the technology to go there and find out. Space elevators, once a science fiction dream, might become a viable engineering project, dramatically reducing the cost of getting to orbit even further than reusable rockets. And what about a century from now and beyond? We're entering the realm of truly advanced concepts. We'll likely have large, self-sustaining cities on Mars, maybe even beginning the long, multi-generational process of terraforming Mars, slowly changing Mars's atmosphere and climate to make it more Earth-like. We might have O'Neill cylinders, massive rotating space habitats that create actual gravity, hosting thousands of people in permanent orbital communities. With advanced propulsion systems, maybe fusion rockets or solar electric sails, the entire solar system becomes our backyard. And then we'll look to the stars, the first interstellar probes, robotic precursors to human voyages, will be launched towards nearby star systems like Alpha Centauri. Sending humans on such a journey would require technologies we can barely imagine today, like warp drives or wormholes. But a century ago, landing on the moon was just a dream. The progress we make in this century will lay the foundation for humanity's eventual journey to become a multi-planetary and one day an interstellar species. It's an incredible future to think about, isn't it? From returning to the moon in this decade, to landing on Mars, to mining asteroids and exploring the outer solar system, the next 100 years are going to be a wild ride. The journey won't be easy and the timelines might shift, but one thing is certain: humanity is reaching for the stars, and we are living at the very beginning of that incredible adventure. Thanks so much for watching. If you're as excited about the future of space as I am, make sure to hit that like button and subscribe for more deep dives into science and technology.